Okay, this is lesson 1.2 from your notes, and we're going to be talking about the properties now. We talked about the real numbers, and now let's talk about the properties of all real numbers. So we'll talk about the name and then some values and the main idea. So first property we're going to talk about is the commutative property. That's how you spell it, so let's learn that by now. And it works for addition and multiplication, not subtraction and division. And the main idea is that the order of the values or terms doesn't matter. So that means you could have A plus B, and you know that's the same thing as B plus A. So if you're adding, it doesn't matter what order you add your terms in. And the same thing for multiplication, XY is equal to a YX. So 7 times 3 is the same thing as 3 times 7. And you know that. 5 plus 2 is the same thing as 2 plus 5. So you know that. I know you know this property, but you need to know the name of it. And it's called the commutative. And you got to remember that the order of the values doesn't matter. And I try to learn it by the CO that starts with commutative can stand for change order. It changes the order of the terms. The second property is the associative property of addition and multiplication. Again, doesn't work for subtraction and division. And this is all about grouping. So you would have parentheses and you would group things together, and the order of the grouping doesn't matter in addition and subtraction. So if you have A plus B plus C and you first add A plus B and then add that to C, that's the same thing as if you had added B plus C first and then added A to that, or added that to A. So you'll notice there's grouping symbols, and notice that the A, B, and C order doesn't change, okay? And so sometimes people will say it wrong because they'll switch the order, but the order switching is up in the commutative property. So for multiplication, A times B and then multiplying that by C is the same thing as multiplying A times B and C multiplied together first. All right, so that's like 3 plus 2 plus 5 is the same thing as 3 plus 2 plus 5. Or that was for addition. For multiplication, it'd be like 7 times 2 times 4. If you do 7 times 2 first, that's the same thing as 7 times 2 times 4. And we do this a lot. We do associative property when we're trying to do math in our heads. So all these properties, really. The identity property means that of addition and multiplication means that you add or multiply something that stays the same. Stays the same. So you don't change your identity. Think about it like that. You keep your identity the same. So what do we add to A? What do we add to A to just get itself back again? And that would be 0. So 0 is called the additive identity. When you add it to something, it doesn't change it. Okay? And then multiplication, what do we multiply by A to get A? And the answer is 1. So 1 is the multiplicative identity. Okay, so those are the first 3. Let's go to the next set. Okay, the inverse property is of addition and multiplication. It says, what do I use to get, well, you kind of have to know what the inverse, or to cancel a value, to make it go away. So you use the inverse to make it go away. So the opposite we would put here. Use the opposite to go away. That's called the inverse property. So let's think about it. A plus what gives us 0, which would make it go away? And the answer would be negative A. So that's why you add the opposite. Now what do I multiply by A to get 1? We're never going to get 0. Okay, that's a 0 property if I multiply it. So how do I get 1? And that would be 1 over A. So the inverse of A is negative A, if you're talking about addition. And the inverse of A, if you're talking about a multiplication, is 1 over A. So it matters which one you're talking about, multiplication or division. The zero property says that multiplying by 0 always equals 0. And so it's just multiplication. So 17 times 0 equals 0. Or negative 1 over A times 0 equals 0. So I know you know that, but you need to know it's called the property of 0. All right, and the distributive property I know you've learned in the past. It's when you multiply a value to an expression inside parentheses. So for instance, A times B plus C is equal to AB plus AC. Also in subtraction, if you had AB minus C, is AB minus AC. So that's the distributive property. Let's put numbers in it. 2 times 5 plus 3 is equal to 2 times 5 plus 2 times 3. Now, sometimes it's easier to just go ahead and add 5 plus 3 and times. That would be 8, and 8 times 2 is 16, or 10 plus 6. So, but sometimes, not a lot of times, sometimes it's easier to use the distributive property to figure it out because the numbers might be bigger, and you can do these numbers in your head versus multiplying by this added together. So that's the distributive property. A couple more. The reflexive property. Okay, so this is like a mirror. It means like a value always equals itself. So A equals A. All right, so 16 equals 16, 5x equals 5x, 4y squared has to equal 4y squared if it's reflexive. Now, symmetric says that if you have an equality, like if A equals B, then B equals A. So it doesn't matter which side of the equality you put something on. If they're equal to each other, it depends. If you're looking on the left, it equals the right, or the right equals the left. So you would say if x equals 3, then 3 equals x. And that's when sometimes in solving equations, we put things on the other, we switch the way, like maybe the variable's on the right and we want it to be on the left. So in other words, if we're solving for like 2 equals, okay, wait a minute. How about I say 12? Really easy. It's not 12. 12 equals 6x. Well, maybe we like seeing 6x equals 12 and working from the left. So this is the property that lets us change it and put the 6x on the left and the 12 on the right. Got it? Called symmetric. Okay, and reflexive. These are the ones people get confused. Reflexive, it equals itself. Symmetric, you can switch on either side of the equal sign. So it has like symmetry, if you kind of look at it like that. And the transitive is the one that involves 3 things. It says if A equals B, and then you have B equal another number, C, then logically A equals C, okay? And that's the transitive property. So if 4 plus 3 equals 7, and 7 is the square root of 49, then 4 plus 3 equals the square root of 49. So you kind of eliminate the middleman there in the transitive property. All right, so those are the properties. Now let's talk about closure property. So you call a set closed under like an operation like addition or subtraction if the operation always produces an element of the same set. If an element outside the set is produced, then the operation is not closed. So let's talk about this. Are integers closed under multiplication? So so integers, this means, okay, so you understand, I multiply 2 integers together, do I always get an integer? So say I have -7, that's an integer, times 3, that equals -21. Do I get another integer. And do I always get another integer? And the answer is, for this case, yes, I would always get, I can't think of any examples, and logically there doesn't exist any, where you would get something other than an integer if you multiply two integers. So this one is true, and I can't come up with any counter examples. Now our natural number is closed under subtraction. So that means if I have like 5 minus 2, that's equal to 3, right? Now, that is true. I still get a natural number, but subtraction's funny because you know you can get negative numbers. So if I do 2 minus 5, those are both natural numbers. But now what happened? I got an integer, not a natural number. So this would be false. This is false. It's not closed. Okay? If an element outside the set that is not closed. So this would be closed. And this is not closed. We shouldn't have gone false and true. We should have just said, but I mean, they're asking the question, okay? Even numbers are closed under addition. So when I take two even numbers, do I get an even number? So 4 plus 2 equals 6. Am I ever going to get an odd number if I add two even numbers? And the answer is no, I'm always going to get an even number. So this would be true. Hope you understand this. Irrational numbers are closed under division. So if I take two irrational numbers and I divide them, do I always get another irrational number? And I can think of something here that makes this a counterexample. I can say square root of 7 over the square root of 7. Does that give me an irrational number? No, that gives me 1. So this would be false because I could think of a counterexample. Perfect squares are closed under subtraction. So if I have a perfect square, so 25 is a perfect square, minus 16, that's a perfect square. What do I get? Okay. I get 9, and that's a perfect square, but I shouldn't just assume. Let me try. How about 25 minus 4? And what do I get there? I get 21, which is not a perfect square, so false. You only need one counterexample for the whole thing to be false. All right, so that's the closure property. All right, and that's your lesson 1.2.